Hi, welcome to your first teaching video for the probability topic. The idea of these videos is so that you can watch them, pause them, rewind them, go over them again if there's any details you're not sure about, have the examples that are available to you, but certainly if there's something you don't understand, you need to talk to me about it as soon as possible. So, looking at probability, all of this stuff should be revision for you from your previous years. So, probability is the chance of an event occurring. So, we want to know what is the probability it's going to be sunny tomorrow, probability you're going to hand in your homework, probability of anything. Everything is measured with a probability between 0 and 1. That probability of 0 is impossible, means it cannot occur, and the probability of 1 means that it's certain it must occur. We describe as all the possible results, sample space. So generally things are described in words as if it's between impossible and even, then it's unlikely. If it's between even and certain, then it's likely. We use numbers to write probabilities, so they can be written as fractions or decimals. Try to avoid using them as percentages. You should convert between them using your calculator. When you want to compare probabilities, you should always use decimals. It's much harder to compare fractions. So we've got two fractions down the bottom here, and what we want to do is compare to see which one is more likely or most likely. So first thing we do is 3 divided by 4, so 3/4 is 3 divided by 4, which gives us 0.75. So if we were describing that on the scale, it's more than 50%, so it's likely rather than unlikely. With our second one, it's 2 divided by 6, which is 0.333 recurring. If you're rounding, you could round it to 0.333 and write it as 3dp. It's much more accurate to use the recurring dot. So then looking at those numbers, we're comparing 0.75 and 0.333. The most likely is 3/4, which you'll sometimes hear described as 3/4. Generally, these are the big things you need to remember from year 11, is that all probabilities are found from taking the favourable outcome divided by the total possible. So for instance, if I roll a 6-sided dice, if I roll that, the probability that I get a 4 is 1 out of 6, because there's one possibility, or 1 4 out of 6. Experimental probability is when we start looking at, if I did roll the dice, the probability I may not get a 4 even if I rolled it 6 times. There's a chance that I could get 6s for the first 10 rolls, which would be a low probability. So it's looking at that side of things, but the actual calculation is the same. So if I want to know the probability that that a yellow car comes down the road, okay, well then I need to know the number of yellow cars that come down the road, and then divide that by the total number of cars. And then that would be the experimental probability. Expected number, again, is a bit of an obvious thing. It's the number that we would expect to occur from a given number of trials. So for instance, if I flip a coin 100 times, how many times would I get heads? So because we know that the probability of getting heads is a half, be a half times 100. So these are the main concepts. Your workbook has questions for you to complete on that. If you feel like these concepts you're not too sure about and you need more practice of, what I've done is I've set up a Khan Academy lesson for you. There's a link there which you can follow. You can find that on the lesson page, so that you can click on it. It's a pretty basic setup. You go directly to this page. There'll be a series of steps which you can follow, which also include worksheets and things like that. So I highly recommend that if you did find that last bit a bit confusing, that you spend some time doing that instead of moving forward. However, I know there will be a number of you who won't need to do that. So it's not a compulsory thing, but it is in your interest to make sure you've got that understanding. So just click that link. But if you're happy to move on with that initial initial bit of theory, you can start looking in your workbook at the task on page 7. Pretty simple task. All you've got to do is you've got to go through and have a look at your the different situations. You need to decide whether they're correct or wrong, and you need to justify your decision and why you made that as your answer. So try and do this properly, and try to look back to that theory, trying to think why is it that is correct or possible, because there are some that are impossible. So before you do that, make sure you pause the video, go off to your workbook, or if you're working off the PDF, have the PDF up and have your sheet beside you, and work your way through that. Once you've finished the task, come back to this video and then we can take a look at the answers. So hopefully you've completed that task. If not, pause the video again and go back and do it. We'll go to the answers shortly. So here are our answers. So of ones that weren't possible and the ones that are possible. So if we take a look at the first one, Mike calculated that the probability of winning his game was 1.05. Now, the justification there is pretty obvious. It's not possible to get probabilities bigger than 1. So a probability of 1.05 is far too large. Question 2, Miranda wrote down that the probability of getting an even number when a die is tossed is 0.5. The answer he said was a half, so she marked it wrong. Okay, so obviously that's wrong, because 0.5 is equal to a half. So that should be okay. Question 3, 25 members of Archie's class owned a pet. There are 28 in the class. The probability that a class member owns a cat is 28 over 25. It's obviously wrong. The justification, and that's pretty simple really, that we've put the actual fraction around the wrong way. The denominator in probability should always be bigger than the numerator. Again, it's basically the same problem as in question 1, where we've ended up with a probability greater than 1. So it should have been the number who own a cat divided by the number who in the class, which is 28. Number 4, Archie's school, a quarter of the students travel to school on a bus. Therefore, Archie expects that 7 students from his class will catch the school bus. Okay, we've said that's correct. So again, that's going back to Archie's class up here. And he said that there's 28. So if we think back to that expected number, it would be a quarter times 28, which is actually equal to 7, which is what he has said. You can see there exactly that the expected number should be 7. Number 5, Juliet has a 10-sided dice with numbers 1 to 10 on the faces. If she tosses it once, the probability of getting an odd number or a 10 is 1 out of 20, right? So that's wrong, because the probability of getting an odd number is actually a half. Probability of getting 10 is actually 1 out of 10. So if we put those together, the answer should actually be 12 out of 10 or 12 out of 20, 6 out of 10, or 3 out of 5. And obviously the incorrect answer is to get 1 out of 20 by multiplying them together. So number 6, using the same die, the probability that he gets 2 10s when he tosses it twice is 0.01, and that is true. So the probability of getting 1 out of 10, a 10 is 1 out of 10. So doing on your first row is 1 out of 10, second row is 1 out of 10, which is equal to 100. Number 7, Angus calculates the probability it will rain tomorrow, which is minus 0.01. Obviously that's wrong, because you can't have negative probabilities. Number 8, fair-sided dice is tossed once. Probability of getting a 2 or a 3 is 1/3. That's correct, and it's because probability of getting a 2 is 1 out of 6. And the probability of getting a 3 is 1 out of 6. So probability of getting one or the other, we end up with 2 out of 6, which is equal to it. So, well done to that. What I want you to do is make sure you mark it correctly and really be as accurate as you can, because I want you to make sure that you're able to spot those problems and get those answers correct, because that's basically it for this lesson. But if you're in a situation from that last task that you didn't get at least, or you got 2 or more questions wrong, not in terms of that the actual task was wrong, but out of the 8 questions you didn't get a correct answer, I want you to do that basic probability lesson and go back and complete that. And there's no rush to complete that so much, but there's not much point carrying on until you've done that. The thing, if you got through that okay and you managed to get only 1 mistake or less, then you need to move on to the next task.